Hey, Brother Smith. This is Stephen Costigan, and this is my final project. So I'm going to go ahead and show ticks enabled and reset from the beginning and show you that it works. So I wrote in some basic ASCII code. While that prints, I'm going to show you I made a little thing in Excel for it, so it's pretty cool. It allowed me to create little ASCII codes there, which was really cool. Really helped with this kind of thing where I wanted to be able to write ASCII real easy. So while I'm here, I want to show you one of the requirements was about the minus. So I'm going to show you, this was from my 7 - 3 command. So I've just got here just the logic of that. And if I was to open just the math, it's just this part here. So I wanted to go over that real quick and how that works in my system, both as software and then also as hardware. I know that was a requirement. So I'm going to turn off the ticks enabled because I want to be able to do this slowly. So the first tick that goes through, it's a 0, 0. And then it goes into this one, which is storing to register 1, the half of the bit, which is, as you can see, is 7. So 7 bits will store into this first register, which you can see from the second register, which is register 1 and 0, which will store into register 1. So register 1 will store the number 7 into it. From there, the next bit will store 3 into the register 1, 0. Sorry, I get them mixed up. So the first one was stored here, the second one was stored here. We'll call this one for easiness 2 and 1. So register 2 is holding 7 and register 1 is about to hold 3. On the next stage, the 2 bits are already stored, so we've got 3 and 7, which are then brought down here where write enable and subtract are also on. So we have here, this register here is going to store the output of whatever the minus is, which in this case, you can see is 4. So we have our subtract here going in, this is the hardware obviously, going into the adder and subtractor, going into my 1-bit adders and subtracting and returning the result of 4. That 4 result is taken to this mux here, which is currently the default, which is going to be the default state in a moment, which will then push into here. So we'll show that. So we'll go back to our main, back to main. Apparently I'm unable to do that. There we go. That's weird. So, and then if I press it again, like I said, it'll go from the here, which is the 4. 4 is going out into here where it is pushed into the mux, and then which will then be stored into here. It hasn't obviously done that just yet because it's a 0, 0 signal, but the next one will do that right here. So we can see this mux is being enabled, so it's going to the second input, which is this one, which is then there's our 4. Our 4 is going to be stored into this here because this is where write enable is. So there's our 4, there's write enable. On the next tick, it will be stored there and be ready to display. So then we press it again, and now 4 is stored into that bit. There's the first bit. Then enable. Then we have the next part, which is to display it on the screen, which is the 30. There's our 4. So there's the math of that. So I think that's gone through all the major components of this. Thanks for watching. And also thanks for a great last half of the semester. See you later.